Hello everyone, welcome back to JDCodebase. This is my LeetCode top interview 150 study plan. Today we are going to solve the 12th problem, that is the 380 insert delete get random big of 1. So this problem is not an advanced DSA question. It is a basic data structure problem, something we actually use in general terms but not very. So first let's read the problem statement. We need to implement a randomized set class. It has the four operation. First is the initialize the object. Second is the insert a value if not present. And third is the remove a value if present. And last one is the return a random element. So catch here is the if in the insertion, if value is already present in the set, we have to return the false, and if it is not present, then we have to return the true and also insert them. And in remove also, if an item val from the set if present, then we have to return true and also remove from the set, and false otherwise if it is not present. So here the most important line is the last one. Each function must work in the average big of 1 time complexity. This line changes everything. So when I read the problem statement, my immediate thought was the we need to insert, delete, and check existence in big of 1. So that sounds like a set, JavaScript set, right? So insert in set is the big of 1, delete is also big of 1, checking if a value exists is also big of 1. So for insertion and removal, set work perfectly, but then the third operation comes, the get random. So this is for get random, I thought maybe I can generate a random number and using math.random something like minimum to maximum and return that value. But then I realized something important. A set does not store a value like a continuous range, means value can be anything like 10, 20, 30, 40, 200, -5, even worse. So set does not support random access. I cannot just pick a call an element from the set in big O 1. So this is the where my first approach, my first idea breaks. Next, I thought array also random access, means in big O 1. Array allows the random access, like I can access by array of index. So what if I store all the values in array, and now get random becomes very easy, and I just generate a random index and return array of a random index. But now another problem appears here. If I want to delete a value from an array, first I need to find its index, and finding an index means it's a big of n time complexity. That's break the big of 1 requirement. So now I am again stuck here. At this point I ask one important question: what exactly is missing here? I already have the value, the 10, 20, 30, 40, 50. I just don't know where it is stored in the array, like the index 0, 1, 2, 3, 4, 5. And if somehow I could know the index of a value in big of 1, then delete would also become big of 1. And this is the big insight of this problem. I don't need a set, I need a hash map. And because a hash map can store something very important, and it store value and index, means key value pair. So now my design becomes clear. I will use an array to store the values 10, 20, 30, 40, 50, and a map to store the value index, like 10 is at 0th index, 20 at the 1 index, 30 at the 2nd index, 40 at the 3rd index, 50 at the 4th index. So now how do I delete from the array in big O 1? So instead of shifting element, means deleting here using splice or something, I use a trick called the swap with the last element. The steps are very simple. First, when I get the I get the value to delete. First I check the index of the value from the map. Like if I want to delete the 20, I just check is map dot by using this, and I get the index here, either 1 2 3 whatever index, and then take the last element of the array, this 50, and replace this with the index of that value, means this 20. Now when I update this, my array becomes 10, 50, 30, 40 and 50. So after that, means this index come here, means I get the index 1 here, and I just update the last value with this index value, and finally update its index in the map also, means now 50 is at the one index. Now I have to update the 50 with the 1 here, and finally pop the last element, remove this 50 from this array, and remove this 20 from this map. So all operation are constant time here. So the final design is very clean: array for the random access, map for the index lookup, and swap with the last for the big of one deletion. So this is why set plus array is not enough, because set can tell me if a value exists or not, but it cannot tell me where it exists, means this 0 1 2 3 4 indexing. So let's write the code here. First initialize the constructor this dot array, a blank array, and this dot map equal to new map. So I initialize an empty array and empty map, so these will store my values and index mapping. Next is the for insertion. First I check if the value already exists in the map or not. If this dot map dot has this value or not, if yes, means if it is in the array in the map already, then just return false. Else this dot arr dot push the val, and this dot map dot set with the value is the here key, and pair means key here is the this dot arr dot length -1, because every time when I push the element it move to the last index. Return true. So if it exists, I just return the false, otherwise I push the value into the array, and I store its index in the map as array.length -1. Next, for removing an element, for remove I first check the value exists or not. If this dot map dot has this value or not. If not, return false. Else get the index of this value from this map dot get value. This give me index of this value, and let last value of the array this dot arr dot length -1, and update the last value on the new index, this dot arr on new index with the last value, and this dot map dot set last value with the new index, means I update the map with the last value with the new index. And in last, finally arr dot pop, remove the last element from the array, and this dot map dot delete the value from this, and return the true. So here I just take the last index from the map, and put the last element at the means take the last element of the array here and put the last element at the index of the value to be removed, and I update its index in the map. Then I pop the last element and delete the value from the map, and this keep everything in the synchronized. Last one is the GetRandom. For GetRandom, I simply generate a random index between 0 and array.length. So let minimum value is the 0 and maximum value is the array.length. This dot err dot length and directly return this dot err math dot floor, because math dot random gives the point value like 1.2, 3.2 or 3.6 like that for math dot random, and multiply this with the maximum minus minimum and plus minimum. So let's run this. What happened? Okay, I forgot this. This dot arr dot length. Yes, let's again run this. Yes, it is accepted. So let's talk about the time complexity here. Insertion is the big of 1 and removal is also big of 1 here. No extra searching, no extra sorting. And get random is also big of 1, just a math.floor and math.random for generating the number and a basic mathematical operation. And space complexity is the big of n, yes, because we store the values in the array and the map. So this problem is not about syntax, it about designing the right data structure. If you understand why set failed and why map plus array works, you will never forget this problem. If this video helped you understand the thinking process, like and subscribe to JDCodebase. I am solving LeetCode top interview 150 step by step. See you in the next video.